Hello, everyone. Welcome. Thank you for coming. And today we have a lecture on evaluation, and it's our last lecture in this course. We made it. It's almost unbelievable, but we all survived. I guess. I mean, we don't have as big of an audience as we had in the beginning, but still, most of us survived. And for that, I want to thank you for still coming to the lectures and for still following the course. So yeah, last lecture of the cycle of lectures. Of course, we still have a long way to go with the course, but this is basically where we will wrap up the actual, let's say, passive part, so to speak. And this lecture is on evaluation, and this is based on the excellent material by Dr. Michael Siedlmayer, who is a super important researcher in visualization, a young guy, but has done a lot of important work. So if you're curious, I really recommend reading his papers and looking at his stuff. And these slides are based on his material. So let's start. So basically, we are going to talk about evaluation of visualization under two main, let's say, perspectives, right? After we talk about the motivation, like why do we have to do evaluation and visualization, then we're going to talk about different methods that exist or that are proposed or that have been used in visualization for evaluation. And we're going to look at it from two main perspectives, let's say, so the technique-driven evaluation and problem-driven evaluation. So these are which of these techniques you want to use will depend on, let's say, what is the goal and what are the approaches that you're using in your process of development or the design or the creation of whatever it is that you're doing. So that will depend on what you're doing, and you will see that these are let's say two big different kind of like groups of methods, and then you can even use both of them in case that matters to you, that makes sense to you. But yeah, you can see here we have like algorithm performance, image quality, control experiments, which are for techniques, and also we have observations, interviews, ability testing, and so on for the problem-driven ones. But I'm going to go into details of what they mean later. So let's start with the motivation. What is evaluation, right? So what does it mean to evaluate, not only in visualization, but also in general? Well, these are two very common definitions of what it means to evaluate in general, not only in visualization. So we start from them, and then we try to think about why are they interesting for us, and what do they mean if we put it in the context of visualization. So evaluation is the systematic assessment of the worth or merit of some object. This comes from these Joint Committee on Standards for Educational Evaluation. So it's from an educational evaluation, but still it works also as an abstract concept for us. So systematic assessment. What does it mean to systematically assess something? It means that you want to assess something from the point of view of some kind of a systematic framework. You want to have, let's say, formal or concrete evaluation of something. And sometimes when formal or concrete evaluation is not possible for whatever reason, because what you're doing is, let's say, inherently subjective or heavily human-centered, then you at least need it to be systematic so that your evaluation could be at least compared to other people's evaluations of something else. So even though it might not be formal, it might not be objective, at least if it's systematic, if it has been done according to some kind of framework, then at least it could be compared to something else that has been done by some other person, right? Because if everyone simply evaluates or assesses something according to whatever they think is good at that point in time, then it's very hard to, let's say, extract real knowledge out of it, right? Even though it might feel like it's the right thing to do. And maybe you think, oh, but I can't find a good systematic framework to evaluate my visualization, for example, so I'm just going to create a new one. Well, it may feel like it's the best thing to do or the right thing to do, but the point is that if you do that, then it makes it very hard to really compare whatever results you get to pretty much anything else. And also it makes it very hard to know the validity of what you are doing, because then you have two, let's say, two variables happening at the same time, right? You have the variable of how good is your actual evaluation system and how good is the thing that you are evaluating. So these two things then end up being, let's say, interacting with each other, and then it's hard to really say like which is which. So that's why it's important to be systematic in whatever evaluation you do, even if it's informal. And the evaluation is the process, like that's the second definition. Evaluation is the process of ascertaining value by comparing results with objectives and judging how well objectives have been met in a qualitative and quantitative sense. So I personally like this definition much better, especially when it comes to visualization, because more often than not, the process of designing evaluation, or sorry, visualization, or a visual analytics system is the process of trying to reach some goals, right? I like this definition because it puts in a very important light the fact that before you do it, you need to have goals, you need to have objectives, because then when you do get your results, you will compare them with the goals that you had. And that by itself is a good way to evaluate your visualization, even if even if you don't have anything else that you could compare with, or even if you can't find a clear objective way to compare it with anything else, because maybe there is stuff out there that you could compare, but maybe you don't have access to it. Like, for example, let's say you're building a new visualization, you want to compare it with some other visualization that already exists, but you don't have access to it in order to compare. So all you can do is just compare it with some description, right? So when you set up your own objectives before you let's say design your visualization, then this is a way to kind of do a self-assessment based on the objectives. Because if I'm looking at your visualization and I know, okay, the objective of this visualization is A, B, and C, and I agree with those objectives in a even before I see the visualization, if I agree with them, then I say, okay, these objectives are important, they are interesting objectives. Then when I do see the visualization and I think, okay, it's clear that this visualization reaches the objectives, then that's a one very good way of assessing your own work, or even sharing it with others, because it's not necessarily better than anything else that's out there, or we don't know if it's better than anything else out there that came before, but we know that it solves one or a small set of specific problems that were set as the objective. So I think it's a very important thing to keep this in mind. And I also like when that they say it's on a process of ascertaining value, because getting also visualization, let's say assessing a visualization also cannot be a completely objective thing, because it is inherently human-centered, right? The human-centered perspective is always there. So it cannot be simply a concrete thing where you just analyze a couple of metrics or something. I mean, it can be in some specific scenarios, but in general, there's always some subjective value or that has to be ascertained also, that may simply not be so well defined by one specific metric, for example. And we're going to come back to that, because I'm going to give you a concrete example of how to try to evaluate or ascertain the value of a visualization. And then you can compare that or not with some other visualization if you want to. But you can also just simply do it by by simply evaluating your own visualization. But okay, evaluation is this in general, and why do we need to perform evaluations and visualization? I guess, I mean, it should be more or less obvious. I guess. I mean, if it's not obvious, at least it's hard for me to see, let's say, a scenario where the need for evaluation is not obvious, because obviously anyone can propose any kind of visualization, right? I can just come to my computer, work for a couple of hours, and then create this new kind of visualization, whatever. It doesn't matter, because if I cannot evaluate that, if I cannot somehow say, okay, somehow I'm reaching some kind of objective with this visualization effectively, or with some minimum threshold for efficiency or effectiveness, then what's the point, right? I cannot simply just create a new visualization, say, okay, this is my visualization. I think it's good. I think it's nice. And so it's nice. No, right? You have to say, okay, I created this thing because I wanted to have a new visualization for networks that are directed and have weights on the nodes or something like this. And then I wanted to highlight this and that aspect of the network. Then we can somehow say, okay, the visualization is good or bad or whatever. So the need for evaluation, I guess, is obvious. And some concrete reasons why you evaluate visualizations to ensure quality in product development. This is a very, let's say, product driven perspective, but it's, if you're not in academia and if you're working in a company, you're building some kind of a visual interface, then that is one reason why you want to evaluate, right? You want to ensure quality. You want to compare solutions. So again, if you are going to compare with something else, then you need to somehow have a framework for that. You need to have some kind of a value or some kind of something metric or measure that you're comparing, right? I mean, or at least some kind of subjective comparison or some framework that people will look at one thing and look at the other thing and choose which one is better somehow. So you want to compare. To provide quantitative figures. So even if you're not comparing, maybe you want to have some kind of a quantitative value that describes your visualization somehow, because you want to show this to someone and you want to say, look, these are the numbers of my visualization. This is how good it is, or this is how effective it is, or this is how widely used it is, or something like this. You want to provide some kind of a quantitative measurement on that. You want to get a scientific statement instead of a personal opinion. So again, this is more like an academic approach where you say, it's not just me. I'm not the only one who's saying that this is good. I can actually have like this scientific, let's say, approach to say that there's some kind of empirical evidence, or something that kind of suggests empirically that this visualization is actually good. And it's not just my personal opinion or someone else's personal opinion. To convince your audience, reviewers, and so on, right? So I put this drawings here on the side because I wanted to say, like, these are examples of visualizations that are not good in different aspects. This one has a horrible color map. This one is completely useless. It's supposed to be a network visualization, but it's just completely useless. And this is a dashboard that's so full of stuff that makes my eyes bleed. So these things are like, people have proposed them, right? People have created these visualizations, and that not just because they are good, right? So there's always different perspectives that you can evaluate them. And an evaluation can be done in many different ways. And actually, to be completely honest, it's a very fuzzy subject within visualization, maybe one of the hardest ones. If you're someone who is working with visualization or doing research on visualizations, how to evaluate is very fuzzy, and probably one of the hardest things to like know about visualization, to have, let's say, concrete solid knowledge about it, because you will find many different papers and many different books talking about millions of different ways of doing this. And as time goes by, things keep changing. So you could do it in many ways. You could do it with users or without users. So maybe if you're working more on an algorithm instead of an actual visual interface, then you will do it without users, because you can do some kind of a quantitative analysis, which is something that I do, for example, and I work in my visualizations, which are more like about data mining and mixed up with data mining and things like that. But on the other hand, if it's something that's for sure made to be good for the users, then we have to do some user evaluation. It could be formative or summative. It could, in this the difference here is that you could either do it while you are developing it, so that the results themselves will guide the development of what you're doing. That's formative. Or it could be summative, which is just something you do at the end, just to make to find out whether it's good enough or not, and period. It could be quantitative or qualitative, and this is, I guess, more familiar. So this is the same thing that you have in all kinds of research. So there's research that's quantitative, there's research that's qualitative, and again, depends on what you're doing and what's better in that specific scenario of what you're doing. Could be field studies versus lab studies. You might be better off doing a field study, for example, if you know that there's a lot of people using this thing, and you're interested in knowing how are they doing this. Or on the other hand, you could have a lab study where you control the variables a little bit more, because if you're in the field, then there's so many variables going on that you cannot really control for that. And again, it could be before or during or after the tool development. So as you can see, all of these things, they kind of come together in very different dynamic and non-linear ways, let's say. So it's complicated. And what I'm going to offer you today is just a glimpse of some ideas and some things. But of course, depending on what you're doing, you're going to have to kind of like try to, let's say, think about this and come up with a different, okay, for me it's better to do it with users, and I want to do it in a formative way, for example, and I'm more interested in quantitative measures because of this and that, for example. And there's again, visualization has so much stuff involved in it. It's about computational performance, so it has to be computational or computationally efficient, let's say, right? I mean, if you're doing something that's interactive, for example, it has to be fast. There are all kinds of questions related to human-computer interaction. So there's always a human interacting with the visualization, or at least reading, so to speak, a visualization. So there's usability questions, for example, that need to be considered. There's perceptual psychology, which is something that we have explored in the first couple of lectures that we had, where we talked a little bit. And I'm not sure if we did actually, or if you did it with Andreas. Maybe you did it. I think I took it off because you had that with Andreas, and I didn't want to duplicate that. So, but anyway, I guess you had that anyway. There's this question of cognitive reasoning and sense making, which is more about like how to actually, let's say, move towards uh, taking some, getting some interesting ideas and insights from this data analysis process, which is also a very complicated thing that comes from psychology and so on, social science, blah, blah. So that also makes evaluation in this very complicated, because it involves so many different things. It's not this kind of like clear cut area that has its own frameworks and philosophies, let's say. And unfortunately it isn't. It involves many different things. That's what makes it interesting and complicated, but also that's what makes it complicated. So that can be good. Complicated can be good, and complicated can be bad, depending on how you see it. So I just wanted to kind of scare you a little bit, but finally I will actually like give you some, more or less, a couple of, this or that, this is something you can do, or that is something you can do. Even though it is complicated, we try to make it a little bit more accessible, even though maybe I'm not sure if we actually managed to. So yeah, and these are some of the things that we're going to talk about today. Actually, like specific, more. I'm not going to talk about in details about everything. It's just just going to touch on some of these very quickly and with some concrete guidelines. But this is more or less of a summary of what's coming in the next few slides. So it's a little bit of actually usability testing. I'm not going to talk too much about that, but a little bit about rapid design, controlled user experiments, which is a little bit controlled user experiences in a bit more details, field studies, algorithmic performance, and site-based studies. So when to use which, right? Out of this, all these possibilities, when should you use which one? Well, it comes down in a general way. It comes down to this kind of two big perspectives, which are technique driven or problem driven. So it depends on what kind of evaluation you want to do. If you want to evaluate your techniques, or if you want to evaluate the ability to solve a problem. These are slightly different, and let's see if I can make it clear for you. So technique driven. The scenario where you would want to do a technique driven evaluation is when you build something. So I build this new thing, and this new thing is good or better than what we currently have, or I currently have, or the world currently has. So I have proposed this, let's say, new visualization, or this new visual analysis pipeline using existing visualizations, or this new interactive approach for an existing visualization, or something. I have proposed this new thing, a visual encoding, something like that. And now I want to show that this is good by itself, right? Just like it's good, period. Or I want to show that it's better than what already exists. These two things can be done together, or depending on the perspective, or depending on the scenario, you can just basically you're just interested in showing that it's good. You don't have to necessarily compare it with other stuff, but sometimes you have to, because if you're trying to propose something that is supposed to be a competitor to some other well-established technique or algorithm or encoding or whatever, then probably if someone looks at that and say, okay, okay, but how is it better than that other thing that we're already using, right? Because we like that and it works, but now you're proposing a new one. So can you please just like give us some kind of evidence, or at least some suggestion that this is actually better than what we have? Then this is also a technique driven evaluation. And this good or better can be many things, right? It's like, what is good? Like, oh, this visualization is good. Well, why is it good? Is it good because it helps you do something faster? Or on the other hand, it is faster by itself because maybe it does something that is similar, but it does it faster, but it runs faster. So something, maybe you're using some kind of a visualization technique that takes 5 minutes to run because it's there's some kind of a complicated data mining or machine learning, for example, that's running on the back end, and you need to wait for that. Well, then I come and I propose the same thing or something very similar, but it takes 1 second. So that's one way that you can be good, better. But you can also be good, better because the user can actually perform the some task faster, right? So maybe you have some kind of exploratory approach that then you take what already exists and you ask the user to do something like, hey, find the node in this network that has the largest page rank or whatever, find the 10 largest page ranks in this network using the visualization or something like this. And then you show that by doing something else, the user can do the same task but much faster. Something like that. That's also a way to be, good or better. Or maybe there are less errors, right? Maybe your approach generates less errors than the previous one, both again in terms of the actual algorithm or the user, or errors when the user is interacting with it. Subjective user preference. So maybe you just have two things and you say, okay, some people will use this one, some people will use that one. Then I'm just gonna ask them, which one do you prefer? I don't know why. I don't care why. Your brain is a black box. So just tell me which one you liked better. And then you find some kind of a significant result that shows that people simply like your visualization better than the other one. That can happen. I mean, we're not supposed to explain everything perfectly, right? I mean, sometimes it just happens. Amount of insights that you can get from the visualization and so on. So these are just some examples of things that you could consider as being like good or better. And when you do technique driven, usually you do that at the end of the project, right? Because this is not the kind of evaluation that gives you, well, I mean, you could, but let's say in general, this is not the kind of evaluation that gives you some specific pointers on where to go. It just say it's good or it's bad, and if it's bad, then you simply have to do something to make it better. It's not that clear, like exactly why is it. Like, okay, mine is I compare it with someone else, something else, and then I realize that the users take longer time to do a task in mine visualization than the previous one. Why? I don't know. So then I have to find out somehow. Then maybe I can ask questions, or I can make a questionnaire with and try to debug, so to speak, the problem. But still, it's more or less something that's usually done at the end of the project. It's also probably the most common type. That's the most straightforward, the thing that you think first when you think about evaluation. And then there's problem driven evaluation, which is basically like you're working with users that have problems, they have data, they have problems, and you want to design a viz tool for them, right? And you want to validate the design. So in this case, you usually do the evaluation along the entire design process. So you don't want to, for example, talk to to someone who has data, they give you the data, and then you go away for 6 months, and then you come back with something and you show it to them, and they say that that is, I don't like that, or that makes no sense to me, or that does not help me in any way, or something like that. You don't want that, right? That makes no sense. So you, in this case, if your perspective or scenario is that, look, I'm going to build this thing, and I want to make sure as we go, that it is going in the right direction. I want to make sure I understand what's going on, because usually when you talk about, when you do like this kind of design for users, and they have data, they have problems, and most of the time you are not one of them, right? So you are not part of this group of people that you were solving a problem for. So it's the first thing that you have to do is to take a step back and say, hey, I need to understand what's the problem here. I need to understand who is going to use this visualization. What is the problem that I'm trying to solve here? And then after you make sure that that you know that, you start to design the tool, right? And then while you're designing it, now assuming that you understood the problem, and I mean, if you didn't, then you have to assume that anyway. Then you're designing the tool, and then you have to think, okay, is this usable? Like, okay, let's say I am solving the problem, or I'm at least moving towards solving the problem, because I assume that I understood the problem. But is this thing that I'm designing usable? Like, is this something that actually they can use, whether it solves the problem or not? And then afterwards, and so you do this towards through all the process, and afterwards you have to ask yourself, is this thing that I built good? First of all, like, it doesn't make sense. Is it good? Yes. Is it better than what they had before, if they had something before? um, then these are things. So in this case, you have to ask, well, how is it that the people are using it actually after it's deployed? Or are people using it at all, right? Does that fit in their existing workflow of the daily basis, let's say, that they have, or is it something that's disrupting the work somehow, or the environment, and so on? So these are potential questions that you could ask yourself afterwards, considering that you assumed or you understood the problem, and you managed to do like a usable tool. Because maybe you have the best tool, it's super usable, you understood the problem, but it simply doesn't fit in their workflow for some reason. It happens a lot, people are very resistant to visualization if that's not something that they are used to having, like, in the daily basis. So sometimes there's a barrier that you need to take down. And now I'm going to talk a little bit in more details about some aspects of technique-driven evaluations, which is that the first one that we discussed, where you have something, you build something, and then you just want to know if that is good or better than something else that already exists. Okay. So, algorithm performance and image quality. This is probably, let's say, the most straightforward, or the one that is, let's say, closest to, for example, when you have some kind of like data mining or machine learning approach where you're just running some experiments or some empirical experiments. Maybe you don't even need users for that, because you might just be able to actually evaluate the algorithms by themselves, right? Which, for example, like when we're talking about dimensionality reduction or clustering or things like that, when they are applied to visualization, sometimes you don't actually need necessarily. I mean, having users is always better, but don't necessarily need to have. So sometimes you can just kind of evaluate the algorithm by itself using some kind of a objective measure. In this case here, I'm giving an example of complexity. So sometimes you can just analyze the complexity of the algorithm. So by analyzing the complexity itself, you can already kind of say that it's better than something else, because if the complexity was lower than something else that's already out there, then probably it's better. I mean, at least in terms of efficiency, it's better. In algorithmic, in terms of algorithmic performance, it is better. And there's also the case of scalability. So maybe the complexity is the same, but you have managed to make it more scalable in let's say in a more practical way. Let's say theoretically it's the same complexity, but in practice it's more scalable, because you can I don't know, break it down into different parallel flows or something like this. So then you can talk about interactivity, resource constraints, or it's easier to run because it's maybe it doesn't load everything to memory, and it uses the disk in a smart way, so it's a little bit more scalable. You can use it in a desktop and you don't need a server or something like that. So these kind of things, they can be used also in visualization, depending on the kind of visualization that you're evaluating and the kind of evaluation that you're doing. But you can do that, especially when you have more algorithmic, more let's say data heavy stuff instead of actual more human centered aspects, right? So that's from the algorithm side. You can do that, and then it comes from let's say image quality. So for example, there are quantitative metrics to determine the quality of an actual visualization, right? Um, some visualizations are more they lend themselves better to these kinds of things. Like for example, in this case, I'm showing here a table or an example from this paper called Metrics for Graph Drawing Aesthetics. This is something a little bit like what you've seen a little bit with me, and probably also with Andreas, about graph drawing. And there are some ideas or some measures, or let's say some aesthetical aspects of graph drawing that are known to be more interesting for users. So if you can actually measure them, you don't need to necessarily have users or people looking at the graph drawing and then extract that from them in a questionnaire or something like this, because there are some measurements. I mean, there is a lot of empirical studies that have been done before to determine that, but there are some things that you can actually measure. And for example, line crossings in a graph drawing. If there are too many line crossings, then we know that that is not a good thing. So the more line crossings you have, the worse, theoretically, the worse is your drawing. So you want to strive for drawings that have less line crossings, and you don't need a user to tell you that. This kind of thing that you can actually take the visualization, the image, so to speak, that you generated, and from that you can already determine that, like the area of the drawing, the sum of the edge lengths, the sum of the edge lengths or uniform edge length, they're like similar. But for example, it's also kind of known that uniform edge lengths usually are connected to better readability of the graph. So if you have uniform, the more uniform are the edge lengths in the drawing, the better. And this is again something that you don't need a user to tell you that. You can measure that from the image itself. So you can say, someone comes with a new graph drawing technique. Oh, I've created this new graph drawing technique, which is better than everything that's out there or something. And then they themselves, they can already compute this thing and report on that and say, look, my technique has better uniform edge lengths than these other competitors or something like this. And again, it's a very objective way to do it. And it is one possibility of doing it depending on the kind of visualization that you're doing. It also can also be done with scatter plots, for example. There are ways to try to measure if a scatter plot is better than another scatter plot, or if two techniques that generate some kind of a scatter plot visualization can be compared by looking at like density or how many, let's say how clear the clusters are and things like that. So these are objective things that you don't need a user in order to evaluate. You can do it yourself just by computing it from your visualization. And you can also have qualitative discussions on the results of algorithms, but I mean, it has, first of all, it's a problem because someone can just say, look, this image is great, and I mean, how can you measure that, right? But at the same time, there are things, there are situations when a user can just look at something and say, this is good because for example, in this case, this is good because I can see 5 separable clusters with different colors. Even though it's not the clearest thing in the world, but at least I kind of see here, if I look at it, I kind of see 5 separable clusters here. But on the other pictures, I don't see that. And this is the kind of thing that's very hard to actually measure with. I mean, maybe you can come up with some kind of a measure for that. It might be possible. But at the same time, it's not super easy because you see the clusters, we see the clusters, but it's to define them in a mathematical way, like how to extract them, might not be the easiest thing in the world. So in those senses, sometimes it is, image quality itself can be used. Like for example, you can, if you're writing a paper and you have a technique and you have generated some images, and you don't have a specific objective measure to show that yours is better, but you can see that it's like, for you, it's clear in the image. So what you can do is argue, right? I mean, if you can argue with reviewers, or if you can argue with someone else who is evaluating your visualization, if you can show a picture and say, hey, let me argue with you why this one that I did is better than this other that came from before. This might not be the most concrete, most objective way to evaluate, but it is possible. It's not always possible. If you give me two images and you tell me, look, this one is better than that because of this and that, and I just cannot see it, then I guess that's it. I mean, unfortunately, since it's informal and subjective, it could happen. But at the same time, again, if someone came to me with these 3 visualizations, say, hey, you can see the clusters in this one, but in this one they're kind of like dispersed, and in this one I have no idea what's happening here. So I would be willing to kind of like accept this. I'm not saying that there are no other ways to do it. I can probably think of a few ways to make this more obvious, but at the same time, I cannot say that there is some kind of like super straightforward technique to do that. So I'm just saying that this is also a possibility. And then comes controlled experiments, which are, let's say, probably I wouldn't say the most common, but I think it's one of the most, let's say, the one that you think about when you think about evaluating something, right? We're kind of, let's say, we have been, in a way, conditioned to think of controlled experiments as these perfect things that answer all questions about the real world. They're not, but still, it is one important tool in any kind of research, right? There are many names that people will give to that, like a lab study or an A/B testing. I've heard that before many times. It took me a while to understand that actually an A/B testing was the same thing as a control experiment, but it's something people say as a user study or something like that. So usually these are the comparative ones, right? This is the one you use when you want to compare something. Like when the canonical example of when you propose a new medicine and you want to test if the new medicine actually works, right? So you take a few people, take a bunch of people who have the same disease, and then you randomize them into two groups, and one of them will take the medicine, the other won't, and so on. So the most common goal here is that you want to compare, right? So is your novel technique better than state of the art? Okay, state of the art of it. State of the art techniques, faster, less errors, more insights, and so on. Then you do a controlled experiment. And a controlled experiment, in a very, very, very general way, it works with visualization. Actually, it's very common, and I would say it's a very good way to ascertain, let's say, the value of something that you have built. It's a very convincing one. If you can make a kind of a control experiment like this, if this is under your reach, let's say, that's something that you can find people to do it, and you can find another technique to compare to. I'd for sure suggest, and I would let's say, well, I would say it's a good thing for you to do. So if it's in your reach, and basically that's it, right? You have your cool new visualization that you proposed, number letter A. You have letter B, which is something that's already out there. uh, I mean, of course, not only something that's already out there, but also something that is comparable to what you are um, to what you're comparing. Sorry, comparable to what you're proposing. And it should be like the state of the art, because I mean, why would you compare to something that's not a state of the art, right? So then someone might simply ask, well, I understand that you're better than this thing, but I don't see how you're better than the actual state of the art, right? So it has to be something that's well known and recognized as being, let's say, a front runner of whatever it is that you're comparing with. So you have these two things, and then your question is, well, which one is better, right? And you hope that it's yours, but it could be and might also not be. Well, test it with the users. So if you're asking which one is better, then let's test it with the users. And the normal let's say flow of a controlled experiment is the same as you have probably seen somewhere else, I guess, at this point. Being a master or PhD students, I'm assume that you have seen, or that you have at least read about a little bit about what is a controlled experiment, right, and how it works. And basically, you start with the hypothesis development, and I will actually talk a little bit about in details about this, but so I will not get into details now. But yeah, I start with the hypothesis development. So determine your hypothesis comes before. Then you identify what are the independent and the dependent variables that you want to that you're gonna well, the dependent variables are the ones that you're going to measure, and the independent variables are the ones that you're going to like eliminate, or sorry, manipulate or eliminate, depending on what you want to do. Some of them you will manipulate because that's what you want to test, and some of them you will try to eliminate so that they don't affect your experiment. And then after you've observed the dependent variables, then you're going to apply some kind of statistics in order to determine whether what you can let's say what you can get from the hypothesis that you defined in the first place, right? And then you get some results with some kind of a degree of certainty. So usually you're never going to say I'm absolutely sure of this and that after an experiment, but you usually have some very interesting, let's say, tools to determine the degree of certainty of your conclusion, right? This is the nice thing about statistics, is that there's always error, because there is always errors. But if you do the statistics nice, then you can actually kind of determine what is the range of your error or the expected range. So if we go in a little bit more details about control experiment, and I think it's important to do that because it is very common and it is a very, very important tool for any visualization designer to be able to do a control experiment or an A/B testing. That's why we get a groups A and group B. So the first thing is that you develop your hypothesis. And that has to be done before the experiment. That has to be done before everything else. And ideally, that those hypotheses should be evaluated by themselves against, like, if you have access to an expert or someone who can actually look at your hypothesis before the experiment and say, yeah, this hypothesis makes sense, then that's the ideal. Because if you do this afterwards, then basically you can make them into whatever you want based on the data that you've gathered, and that's not how you do it, right? Because if you do that, then you're not really testing your hypothesis. You're just trying to extract whatever you want to extract from the data. So you must do that beforehand. So you have the hypothesis is a precise problem statement. So this is the point where you have to kind of somehow establish what the problem statement, what is the problem that you're trying to solve in a very, very, very concrete way. You need to have a concrete problem statement, because that's how, sorry, I'm getting a bit distracted. You need, your hypothesis must be precise and must be concrete, right? For example, my hypothesis, in this case, not the null hypothesis, but the alternative hypothesis, is that for a given task, participants will be faster when using visualization A than using visualization B. Very common, very standard kind of hypothesis, right? I think that my visualization A is better than visualization B. And better in this case means that participants will be faster. So they will do the same thing faster. And my null hypothesis is that there is no difference. So I don't know if you guys have studied control experiments before, but the null hypothesis is usually that thing that you're actually testing for. Because that's what you think it's not true. So it's I'm testing for the null hypothesis that there is no difference in speed, right? But I'm hoping that actually I'm going to reject that hypothesis and there will be difference, and hopefully the difference will be in favor of A and not in favor of B, right? So so yeah, it's a precise problem statement. Usually, as a null hypothesis, usually it's like the opposite of what you actually think. So the H1 here is what you think, and null hypothesis is the opposite of what you think in this case. And in all cases, actually, well, most of them. Then you have to identify independent variables. What's an independent variable? An independent variable is a variable that you as the designer of the experiment, you can manipulate it, right? This is what it means to be independent, because it's not depending on anything. It's actually, sorry, I opened the chat. Yeah, sorry guys, I got distracted a little bit. Yeah, Daniel, it's okay, no problem. I just have to turn off the sound that it makes when you join, because that's what kind of makes me a little bit distracted. And I'm sorry guys, I need to do this, because or else it's play sound when someone joins. Yeah, this is the thing I have to disable. And I've also disabled the waiting room, so I don't have to so it's okay if you leave and come back in, because then I don't have to actually put you in, because that was also distracting me a little bit, but I should have disabled it. It was my fault. All right, let's go back to independent variables. Dependent variable is the one that you can manipulate, and that's why it says independent, because it doesn't depend on anything. A dependent variable, the value of a dependent variable is affected by the independent variable, but the independent variable is let's say free, so you are free to manipulate it and to change it as you want, because that's the actual factor that you're trying to measure, right? So for example, in an A/B testing or in a controlled experiment, the independent variable is what technique is being tested. That's the only thing that changes. Well, hopefully that's the only thing that changes between the two groups A and B. It's the technique that's being tested, and that's the independent variable. So for example, it could also be different visualization design or interaction techniques instead of the actual visualization technique. It could be different test types. So maybe it's the same visualization, but you have different tasks for whatever reason you want to test that. Like how which of these test types is faster or has more error or something like this using the same visualization. Could be. So you vary the test type between the A and B groups, and then you test for whatever it is that you want to test. Then you are like participant demographics, experts versus non-experts. So again, maybe you have the same visualization, the same system, but you want to compare the performance of experts against non-experts or something like this, right? So you can control that. And I mean, the control is of course limited by the length of the study and the number of participants. So I mean, the more complicated is the experiment, the harder it is, let's say, to control the independent variable. But that doesn't matter too much. It's just details. Then you have the control environment, which is like you have to control the environment actually, because you have to make sure that nothing else could cause your effect. So you not make sure, but I mean, make sure maybe it's too much, but do your best to make sure that there are no external factors that could actually cause the same effect that you're trying to measure, right? Because you're trying to measure an effect that comes from the independent variable. You're trying to measure the effect of changing something into A and B. But if there's something else external that is causing the same effect, then all of a sudden this gets very complicated, and then you're going to get bogus results, right? So these are the so-called confounding variables, which are variables or things that could mess up with the results of the experiment because they could somehow change the values of the dependent variables, and they are not related to the independent variables. So you must minimize that. And the best way to do that is by randomization. And I guess this is like basic again statistics. So for example, in this case, you might say, well, I'm putting women in group A and men in group B, and then I'm going to measure. And then women, for example, in this case, were faster than men. Yeah, but how can I know if I have two different things happen at the same time, right? I have different visualizations for A and B, but they also have different people. So how can I know that the fact that they're faster is because they're women, or not because they're women, but because of some latent confounding variable that comes from the fact that they're women? Maybe, I don't know, for whatever reasons, there is some kind of a latent confounding variable that makes it that women are faster in doing this task. I don't know. It's just like a simplified example. But what I mean is that I should not let external things affect the results. So the best thing to do in this case is actually to say, okay, you know what? Instead of putting all women into one group and all men into the other group, or what's more common, in order to make sure that the gender is balanced, let's say, between the groups, I will actually make sure that both groups are randomly assigned between men and women so that they are at least theoretically diverse. And then I will say, okay, maybe women do this better than men. Who knows? Maybe. But if they do, it doesn't matter, because since I randomized them into the two groups, then this latent confounding variable is actually going to affect both groups at the same time, right? So and that's the, let's say, the humbling part of being an experimental designer, is that you're not actually thinking, oh, I am like the superior thing, being that I know exactly what are the confounding variables and I'm going to remove them from my experiment. No, you can't do that. Actually, you have to accept the fact that you cannot do that, and you basically have to say, okay, I cannot do that, but if I can't do that, then I'm simply going to randomize everything so that whatever effects are latent or confounding or external, they are going to affect both groups at the same time. And then let's see what happens. So if these confounding aspects are indeed affecting both groups at the same time, then if there is a difference at the end between group A and group B, then I can assume that that difference came from the actual independent variable and not from something external, because I'm assuming that something, whatever external exists, is actually affecting both groups at the same time. Okay, so randomization is probably one of the most important, it's not the most important part of designing an experiment. And this is not the only way you can do it. There are other ways depending on what exactly you're trying to do, but usually some kind of randomization is necessary. And then comes the definition of your dependent variable. So you've defined your independent variable, like what you're going to change. You defined how you're going to separate people into the groups and control the environment. And now you have to determine what is it that you're actually going to measure after the experiment or during the experiment, actually. This is the dependent variable here. Again, it's called dependent because this is not a factor that you are changing, right? You're not manipulating that. That comes from, hopefully, the manipulation of the independent variable. So it's like a function of the independent variable. You measure that, but you don't manipulate that. And that's why it's called dependent, because you assume that the value is dependent on the other input or independent variable. And this is the one thing that you say that you're trying to determine that it's better. Like this is the thing that you're measuring, right? And usually it's some kind of a performance indicator. So often it's task completion time, the rates of error. So how much people have made mistakes in the visualization according to a certain ground truth that you know is something that they should be doing. And then they don't do that. And you can measure the rate of error between the two different visualizations, for example, or completion time. But it could be also something a little bit more subjective, like the number of insights as reported by the user. So you can ask them to actually say, hey, every time you have an insight about this visualization, every time this visualization gives you something that is new and you think it's interesting, take a note. Oh, I found out that this or that. And then afterwards, you can actually measure like how many insights each of these visualizations actually generated in the users. And then you can compare them, for example. There's also subjective participant feedback, which is also like very interesting. And even if you're doing a quantitative experiment, it's usually a very good idea to have subjective participant feedback at the end. So after everything is done, you can have some kind of a subjective like satisfaction ratings, or you can do a quick interview with the person and ask them some questions about what they did, or you can actually give them, which is I guess more common, is to just give them a questionnaire with some things to answer, like did you like it, what's the grade, what's the score that you would give from 0 to 10, did you think that it was easy, how easy was it to use visualization, did it make your head hurt, or was it like something that you enjoyed, or something like this. You can make a questionnaire even if you're doing some other kind of objective data gathering, like task completion time or error rates or something like that, because this is something that can give you interesting feedback in order to improve or to report on that feedback if you're writing a paper or something like this, or if it's something that you have to report to your boss, or I don't know, that's going to be, you can bring back to your group, development group, so that you can think about what to do with that. And otherwise, you can actually just observe the people who are going through the experiment, right? You can somehow just observe what they're doing, their behaviors, if they're angry, if they're frustrated, if they're happy, if they're laughing, or something like this. Actually, one interesting thing that people do a lot is this thing called a think aloud protocol, which is supposed to be like this thing where you say, hey, as you were going through the system, as you're performing these things that I've brought to you, please think aloud. So whenever something pops in your mind, just say it, right? Oh, I found it very hard I was looking for a button to do this thing and I couldn't find it for 5 seconds, something like this. Or, oh, that's really nice, I didn't know that this thing was going to pop red after I did that, and that was a good surprise, or something like this. So you can ask them to think aloud, and then you take notes or you record that. And then afterwards you make a report out of that. So that's also something that's usually quite common to do. And now I'm going to talk to you about this thing called the value-driven visualization evaluation, which is a concrete example of the kind of questionnaire that you can give to a person when they are when you are performing a controlled experiment. Whether your controlled experiment, it could be a normal A/B testing where you have two groups, but it could also simply be that you're just trying to gather some feedback on how good your visualization is, period, even if you're not comparing it with anything. So you this is an evaluation methodology that basically, it's basically a questionnaire that people will answer after they've done something with the visualization. So somehow you give your visualization to whoever is going to evaluate it. Then you tell them, look, I want you to do this and this and that, perform these tasks. Or you can just say, please use the system freely for 15 minutes and then filling this questionnaire. But it could be also, depending on how self-explainable your visualization is. Sometimes it is, but more often than not, you actually ask the users to perform some tests, like load a data set like this, and then try to find the trend for this and that, or look for the most salient group of blah, 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 something like this. Then you give these tasks, and then afterwards, they're going to evaluate the value of your visualization. So it's more about the ICT methodology itself is more about trying to discover the value of the visualization than actually trying to discover how efficient it is in like reaching a certain goal or something like this. Okay. And this was the specific thing that the guy who proposed this wanted to go for. He said, okay, obviously you can measure how effectively a visualization is, or how effective visualization is towards like some very specific goals, like find the group, find the groups, or find the data set or the data value that is about this or blah blah blah. But that's not all that is important about a visualization, because you might do the same thing without visualization, like you might do the same thing by applying data mining or by querying the data set or something like this, and it would be very hard to compare these two things. So it's important also to understand the value of the visualization itself, right? And then he came up with this framework, ICE-T, so to speak, which is basically 4 different aspects that when they're summed together, they give you the final value of the visualization. So it's insights, confidence, essence, and time. And let's take a look a little bit at each of these in detail. The I part is insights. So a visualization's ability to spur and discover insights and or insightful questions about the data. How much the person who uses your visualization, how much they think that actually brought some insights to them. So if they will give a grade to this. Then a visualization's ability to generate confidence, knowledge, and trust about the data. So how much, by using the visualization, how much that the user has confidence in what they're doing. Like, do they believe that actually, okay, I'm confident that I understand what's going on in this data, and I'm confident about this operations that I'm doing, and so on. And not only in terms of like how much I know about the data, but also how much I'm confident in what I'm doing, right, with the data. And also a visualization's ability to convey an overall essence or takeaway sense of the data. So can I, after I use this visualization, do I have the feeling that I got the essence of the data? So did I actually take something away from it? And also time. So a visualization's ability to minimize the total time needed to answer a wide variety of questions about the data. So it should be fast, should be efficient. It cannot be just something that takes hours to do, right? Unless it's something like super complicated. So maybe hours is not much, but still the perception of the user is that the time was like at least efficient enough. And all of this is done through this questionnaire, which is available online. I I have a link on the next slide, but I should have probably put it in this one. But it's basically this one. And you can see that it's, you have here insight, time, essence, and confidence. Each of these big areas, let's say, or big chunks are divided into 2 or 3 sub, let's say, branches. I'm not going to read all of them here. You guys can read them later, of course, but you can see that it's kind of like a tree. It's a tree, right? And then each of these, let's say, sub branches have the leaves, and the leaves are the actual, let's say, questions that the person is answering, right? So, for example, for insight, we can have a sub branch here that says the visualization facilitates answering questions about the data. It's like you're affirming that, right? The visualization facilitates answering questions about the data, and then the user will rate that. And for example, one of the questions here will be like, the visualization facilitates perceiving relationships in the data, like patterns and distributions of the variables. Again, it's you're affirming this, and then the user will say, well, either I strongly disagree, or I disagree, or all the way to I agree, or I strongly agree, right? And there's 1, 2, 3, 4, 5, 6, 7 ones. So the fact that there are 7 means that there is actually a middle one where you say neither agree nor disagree, because it's an odd number. So, and then there's not applicable, because for some reason maybe they think, well, this is actually not applicable to the visualization that I'm evaluating. And by answering these specific individual questions, you can let's say, aggregate them in, and then you can answer specific, let's say, you can measure the specific value not only of the sub branches but also of this overall characteristics in general. So in order to measure how much your visualization supports insights, then you can measure this branch here, and then you would like sum or make an average here or something like this. And that would give you like the final measurement of insights. Actually, what you should do at the end is not only to have just a measure like an average, but that actually to just check the distribution in general, right? So probably you would want to have some kind of a confidence interval or something like this, which makes more sense if you consider that this goes from like 0 to 6, for example, in a way like a Likert scale. And these are examples that they have published in, actually one example that they have published in this recent paper here, a heuristic approach to value-driven evaluation of visualizations. And this is in this website here, visvalue.org. And I'm just gonna go ahead and tell you that actually you guys are gonna use this to evaluate your own visualizations in the project course. So you're gonna evaluate the visualizations of each other at some point down the line in the course, and this is the questionnaire that you are going to use. And obviously that's why I chose this as an example, and I'm going in details about it. And these are some ways to report the results of this. For example, in this case, they have 3 different visualizations that were actually built by students like you, and these I don't remember exactly if the students actually evaluated each other. I think so, or if they gave this to external evaluators. But basically that's what they're doing here. So there are 15 participants, as you can see here, from the P1 to P15. Each of these participants evaluated the 3 visualizations, right? And these are the scores that they gave. Going from red would be low, and then white would be like average in the middle, and up to, I guess this goes from, let's say, 1 to 7, because I can see 6.89, for example. So and also 7 here. And so instead of like 0 to 6, you would go from 1 to 7. It doesn't matter, right? And you can see that, well, for example, this C, if you look at the overall picture here of the heat map, this C apparently is the not very good one, or at least it's the worst one from the three. And then probably the second one comes Viz A, which is has some red spots and some green spots, and then Viz B seems to be the one that has mostly like green spots, right? In each of the four, how do you say that, big characteristics, I, T, E, C. I don't know for why. I don't know why they didn't order it as ICE, but they actually order ITEC. I don't know why, since it's called ICE in the abbreviation. But anyway, and these are the like final results, the summary results of each visualization. Then you can see that actually this B on average wins over Viz A, and Viz C is the worst one, right? And basically that's one way to like, okay, this is we have this different perspectives, we evaluate them, then we aggregate these values together, and that is one way to kind of like determine the value of your visualization, right? It's one way. And this is the way that you guys are going to do. So you're going to evaluate each other. But me and Konstantin, I will discuss with him exactly the details, and I will let you know exactly how this process is going to take place when it comes time to, probably like this week or the next most. We will publish the details exactly of how you're going to do this with each other's work. Okay. And this was it for the technique driven. So now we should move on to the problem driven evaluation. So again, technique driven evaluation was about this. Okay, I have this thing and I want to measure how good it is, or if it's better than something else. Problem driven is about this idea that, well, I have these users, I have this data, and I need to understand them. I need to make sure I'm building the right thing, and by the end of it, I need to make sure that actually this thing that I built is useful and is being adopted, and so on and so forth. That's why it's called problem driven, because in this case, you're not building just a new visualization. You're trying to solve a problem through visualization, right? And in order to think of problem-driven evaluation, you have to think of three very important milestones during the process of this developing or designing any visualization or something like that. The first one is the problem characterization. So basically, it's like I have to understand the task, I have to understand the problem, make sure that I have that before I go on. Then there's the design milestone, and usually it's let's say the suggestion is to use some kind of iterative process and also usability engineering to make sure that it's usable. And then finally is the validation of the final visualization tool. And in this case, the validation of final visualization tool is usually the same as the technique driven evaluation, because by the time you got to the end, then basically you're just evaluating anyway, right? There are some little caveats, but usually you can just think of the validation of the final visualization tool, the third milestone, as being simply a technique driven evaluation. So when you're going through problem characterization, I mean, this is a very complicated aspect, and it goes all the way outside of visualization. Like you can think of it as software engineering, you can think of it as design thinking. So it's really a very complicated thing, and we are actually not going to go into details here. But in general, the goals that you should think about when you're at this step of problem characterization, if you're ever in a situation where you're talking to a user and you need to extract this from them and build a visualization for them, is basically you have to think at least about these questions, like who are your target users? Are you building visualization for teachers? Are you building visualization for biology researchers? Are you building a visualization for someone who works in industry and is handling like a specific type of a machine? Or is it a visualization for children or something? So who are your target users, right? What are the tasks and the goals of this visualization? This is probably one of the most important parts. And if you overlook this, then it makes it very, very hard for you to actually converge later to a good visualization, a good visual analytics system, for example. which is like, what are the tasks? What do they want to do with this visualization? What will they do with this visualization later? So for example, again, if you're talking, like we have some research, so with Artemis, for example, we have this research that where we are trying to build analytics, visual analytics tools for teachers. So we have to understand what are the tasks that a teacher wants to do with this system. So will they like want to find children or students who are doing good or and separate them from those who are doing bad? What does it mean to do good and bad, right? Are you interested in grouping students into different interests, for example? So some students are interested in a certain topic, some other students are interested in some other topics. So the task here would be to separate them. Do you want to kind of like somehow predict what's going to happen with them in the next couple of weeks or something like this? So what are the tasks? What do you want to do with this, right? And what are the current practices? What tools do they use? So how are they doing it nowadays? Or is it something that they never did and now they want to do it? So I guess not. And even if these current practices or tools are not actually visualization tools, you still want to know it. You still want to know how they're doing it, even if they're doing it on paper, or even if they're doing it in their minds, right? Or even if they're doing it in a meeting where they talk to each other or something. So there's some current practice that you want to understand, because that informs what you want to do. If your visualization, it's complicated if you come with a visualization, with a new visualization or visual analytics tool that completely disrupts the thinking process of your user, and all of a sudden you're forcing them to learn this completely new thing that does not fit at all with how they think about their work, because you believe that it is better. That's complicated. So it's very important that you understand their current practices, even if they don't involve any digital tool at all. Then you have to understand, why are these tools not solving the problem at hand? So why is it that this current thing that they're doing is not efficient or is not effective? That is also something you might want to know before you actually propose something new that they might use. And then why and how can visualization be useful? So even before you start doing the visualization, you have to start thinking like, what is it that the visualization will actually contribute here? Will it contribute because it will be faster? So it will speed up the workflow. Will it contribute because it will be possible to like create and test hypotheses? So maybe your user has a lot of data in their on their hands, and they don't know like what the hell's going on with the data, and they want to just look at it and create some or create and test some hypotheses about it. Or maybe you just want to present. Maybe they just want to present the data that they have and the whatever it is that they're doing. Maybe it's just a presentation problem that you're going to solve. That also can be done with visualization, although we are usually interested in more interactive stuff. But that also helps. So all of these things must be evaluated with the users, right? All of these things must be done through, like, for example, again, some examples here of things that you could do in no without details at all. But you could, for example, just observe them, right? You could say, hey, can I come to your working place for like a couple of weeks and just watch you do what you do, right? I mean, of course, it's never going to be like, so, oh, just watching. I mean, if you have someone watching you, then obviously you're not going to do the same things as you usually do. But anyway, you do the best you can, right? So you just go there and you observe them and you make notes and say, okay, this is how visualization could help. Oh, I understand what they're doing. They're trying to do this and that. So maybe I could do something to help them in this, and so on. Or participatory observations, which are actually observations like you're observing, but you're also asking questions, right? You're asking them to think aloud, like I mentioned before. Even though it's not an experiment, you can ask them like, hey, can you please just like think aloud a little bit while you're doing what you're doing, so that I kind of understand what's going on through your mind as you're doing it. Probably they're going to hate you afterwards, but it's still, if they're willing to do it and if it's something important, and I mean, it's just out of their, let's say, it's not, they're not the ones who decide about this. So they're just playing along together with you. That should be okay also. And it could also be laboratory observation study. So you can actually just kind of set up a controlled environment and tell them, okay, so you come in and you do something that you do on a daily basis. Then you set up some kind of experimental protocol. But they're supposed to do something at least similar to what they do usually on a daily basis, and then you can observe that and try to gather something. Or you can simply have interviews, right? So interviews are a little bit more disruptive, even though everything is disruptive, but interviews are usually a little bit more disruptive because you're actually like taking them out of their environment and sitting down on a table, let's say, or on Zoom, and then having interviews and asking them questions and discussing things and giving them things to think about, and in groups like a focus group. This is a little bit more disruptive, but it can also work depending on how you do it. So these are just some ideas of how you could do it. And this is just about the problem characterization, right? So this is up to the point where you're understanding what they are going through and how you can help. And then comes iterative design. So it's very, assuming now that you have understood the problem, that you have at least some notes and some ideas on what to do, and a concrete objective that you want to move towards. And then you start designing and implementing it iteratively. It's usually outside of fantasy world. It's usually not possible to do this in just one iteration. If you do that, then probably it's going to be very incomplete. So the idea is really to do it fast and to iterate and get feedback and improve whatever you're doing, right? And this is actually what we're doing in our project course, right? And basically, just like a very quick, this again is comes from software engineering, or at least I know it from software engineering. I don't know if it comes from somewhere else, but the idea is to have this kind of like this spiral where you start small and you do a little bit, you analyze a little bit, design and implement a little bit, test what you did with the users. So you come to them with a prototype and say, is this more or less, I mean, it's a very initial thing, but do you think this is more or less going in the right direction? Yes, no, take feedback, go through the loop again. And now the loop becomes a little bit larger because basically the product that you're developing is becoming larger and it's moving away from its starting point, right? And then again, you come back to the user and you show it to them and say, look, again, this is a little bit better than what we had before. Do you think it's going well? Do you think it fits what you expect, and so on and so forth? And you course correct, right? The most important part here is that you're taking the feedback from the user and you're course correcting as you go. And that's a very important part, and don't underestimate this, really, because it's really, really important. This iterative process is really important. And during this process, you might ask yourself, like, is my tool usable? So this testing part here, the gray part here where you're testing, this could be the opportunity of actually doing usability tests in order to make sure that whatever it is that you're building is actually usable. So because we assume that you know the problem now at this point, right? You understand it, although you probably will realize that you don't during this, but that problem should be minimized. And then you're testing if it's usable. You're improving the actual design of the product, so the design of the solution, right? Not the problem itself. And also there's these things that you could be asking yourself or asking the actual people who you're talking to, like, is this effective? Is this efficient? Is this engaging? I guess this is one of the most important things to actually ask your user, right? Because effectively and efficient, this is kind of like something you can actually measure, but engaging, that's not easy to measure. You have to ask them. Is it easy to learn? Also something you have to ask them, because you cannot really measure that very easily. And is it equally usable with different groups? This is also very, very important, very interesting, because if you're if you're always testing with the same person, so you're always bringing your prototype to the same person is giving you the feedback, then you will not really know if this thing that you're building is actually going to be able to be used by other people, right? So it makes sense during this process to try it with different people, to show it to different people who might be potential users of your of the thing that you're designing, right? So to minimize the problem that you might have down the line, where you're actually going to deliver this to someone else, and then those other people, those other groups of people will take them and say, well, I don't understand this. This makes no sense to me, although it makes sense to that other person. So this is also something interesting to keep in mind, is 5 E's, which are maybe measured or maybe actually something that you have to actually get feedback from the user itself. And these are, for example, some examples of things that you can do, like paper prototypes and data sketches. So it's like doing an interview. It's like doing an observation, which is what you did in the initial like problem characterization, but with prototypes, right? So you're doing an interview, for example, but you have a prototype. So you both can actually play with the prototype while the interview is going on, for example, or with something in paper, depending on what you're doing, right? And there's this quote: above all, show them their data. Comes from this paper from Lloyd and Dykes. And basically the conclusion that they had was that no matter what you do here, bring the data, because that's what they know. That's what they want to see. That's what they want to handle, the data. And your visualization is based on the data, so you must bring it to them. And hey, let's discuss this. Is this what you wanted? Is this too far away from what you wanted? Does that make sense based on this, data set that you gave me? And do you see what you expect to see, or something like this? So above all, show them their data, bring their data with the prototypes and within the design, this iterative design that you're going through. And then we come to the actual validation of the final tool, right? Which again is very much like technique-driven evaluation. So you have built something and now you want to know if it's good or better than what you currently have, obviously. So you could be measuring now, after all this, you could be measuring like algorithm speed, you could be measuring image quality, user performance, experience, so on. But if you just do that, then you're missing a little bit more of a holistic view, right? You're missing the context in which the tool is being used. So if you don't have time, you cannot do that, then you can stop at the technique driven evaluation. But if it's possible, like if depending on where you're working, what you're doing, then you might actually go out there and say, okay, let's see how people are using this thing in their actual working environment, for example, or whatever it is that they're using it. And then you might, for example, do a case study on the field, right? There's an example here of a reference, multidimensional, in-depth, long-term case studies is a very important reference in visualization, in evaluation of visualization. And if you're interested, I think this is a very good read. But the idea here is actually like really go out there, and this is a much more subjective thing, right? At this point in time, it's okay to be subjective, because you've been through so much during the development, and if you did it right, you've evaluated your problem characterization, you evaluated your design, maybe you did some kind of a technique-driven evaluation also to do some more objective things. But at this point, if you actually go out there and you talk to people while they're using it, it's okay to be a little bit more subjective and to try to approach this from a more like holistic perspective. And then you ask them, well, did it really help to solve the problems that you had? Did it help you get unknown insights into the data? Did it speed up your workflow or not? Something like this. So at this point, it's okay to be informal. Adoption rates, this is a little bit more of a quantitative thing. You can actually measure this, right? You can actually measure the adoption rate more concretely. So you can check back after some periods of time and see how many people are using this on a daily basis or on a monthly basis. And this will give you some measures that you could not obtain otherwise, only in the field. And one thing that's interesting to know about this kind of validation is that usually the let's say amount of important information that you get from this informal analysis is you don't need so many people as you would need for a controlled experiment. For example, if you're doing a controlled experiment where you have these very specific tasks and these very specific measurements, and you want to have statistical power, so to speak, in your results, then you need to reach a certain number of participants that makes sense to the experiment that you're running. However, when you're gathering these kinds of like informal subjective insights, you're doing a field study or something like this, then usually like 5 people is enough, right? You don't need to also in usability tests, you don't need 30 people as you would in an experiment, for example. And this little graphic over here kind of gives you an intuition about that, which is that by doing like a usability test or a field study with one person, you can already get like 35% of usability problems that you would get, that let's say that the tool has, so to speak. I don't know exactly how they measure this, but probably they had some kind of a tool where they knew the usability problems that were expected to be found, and with one person they found 35%, and as they get to 5 they already have 75%, and then the curve kind of flattens out after a while. So it's not like you get a lot of benefit from having lots of people evaluating your tool, right? As you would in an experiment. In an experiment with very specific concrete measurements, the more people you have, the more the better, up to a certain point. There's also like, you shouldn't just have infinite. Well, you can't anyway, but usually people say, well, you need at least 30, and even 30 is super hard to get to run an experiment anyway. So in these cases, you don't need that much, which is a good thing. And that's it, guys, basically for the lecture today. I have a summary here of the things that we have talked about. And I mean, it's more or less the same as the agenda. You can take a look at this later. This kind of, we talked about methods for technique driven, talked about methods for problem driven. The final takeaway here is that there is no clear cut line. There are many different ways of organizing evaluation and visualization. And it is really up to you and up to your problem, up to your scenarios, up to the things that you're doing. And this is kind of like a guideline. There's some literature here in the final two slides that I guess maybe could help you look for like the most important papers in the area and where you can get some more information about these things based on whatever it is that you are that you need to do. And again, like I said before, the things that you're going to do for this course are using the ICE-T, and we'll get back to you with specific detailed instructions on what's going to happen in that let's say that case. But for today, that's it. Thank you very much for coming. Thank you very much for coming to all the lectures, for being here, and thank you for keeping up with the course. I hope that you're learning something interesting. I hope that you're enjoying it at least a little bit. And that's it for this week, guys. So see you later.